Okay, today's lesson, lesson 33, is looking at some horizontal and vertical circular problems. Horizontal ones are pretty straightforward. It's the vertical ones that require just a little bit more in-depth in the thinking. Now, with horizontal, it's basically things going in a horizontal circle. The best example is cars going around a corner. And again, right here, cars going around a regular traffic circle. So in this first example, we've got basically a circle that has a particular radius, right? We want to know what that radius is. We know that the speed of a car traveling at 110 kilometers an hour. We know that the best friction that you can get is 0.60 between the road and tires. Now, as mentioned before, centripetal force is often like a net force. In this particular case, something has to produce that net force. In the first examples, like for example, in space, the net force is just gravity. For cars and stuff going around on a road, the net force is usually just force of friction. So what we're doing is basically saying that the force of friction is equal to mv squared over r, and then force of friction is u, or mu, Fn. Now, because it's horizontal, we know that Fg and Fn should be equal to each other. So we can just simply replace Fn with Fg, and we know that the force of gravity is mass times gravity. Now, you can actually put in the values in, but mass is found on both sides of the equation, so you should be able to just remove it because it's found on both sides. You're left with a kind of a reduced formula of v squared over r is equal to mu g. All these values we have the velocity at 110. We have the radius that we're looking for, that's our unknown. Gravity, that's 9.81, and mu, coefficient of friction, which is there. Now, the one thing that we do have to, of course, change is your speed. So just like before, if you have 110 kilometers per hour, you have to multiply that by 1,000 meters in a kilometer, and 3,600 seconds. Oops. 1 hour, 3,600 seconds. So you take 110, multiply by 1,000, divide by 3,600, should give us our velocity, which works out to 30.6 meters per second. If you do the math of 30.6 squared divided by our coefficient of friction, 0.60, and gravity, 9.81, we get our radius of 1.6 times 10 to the second. Now, when we get to vertical circular problems, the reason why these are a little bit more difficult is because now your centripetal force is not just one thing. If something is going in a vertical circle like this, you're going to have, let's use a red pen here, you're going to have Fc, or centripetal force, but that's going to be in the up and down plane. You're also going to have force of gravity, which is the up and down plane. And you also have your Fn, your force normal. Now, because we have these three forces interacting together, we have to kind of think about it in a slightly different way. Now, if you read through the notes and stuff, and you read through this here, it may or may not make sense to you. So I'm going to try and clarify it as best I can. If I look at the three forces, as I mentioned, force of gravity, force centripetal, and force normal. They also call it force tension, or tension, because instead of it like being a loop that you drive on, or like a roller coaster, it could be like a string. You're whipping something in a circle. Out of those three forces, which ones stay the same? We'll make a quick assumption. We'll assume that it's traveling at a constant velocity. So we'll say v is constant. So somebody driving in a constant loop, or a constant velocity in a loop. First of all, force of gravity, should it change? No, it's still going to be the force of gravity, mass times gravity. So that's constant, right? Same thing. Centripetal force, if your velocity is constant, your centripetal force should be constant too. Fc is equal to mv squared over r. Same radius, same mass, same velocity, so your centripetal force is constant. With those things in mind, the centripetal force and the force of gravity both being constant, it's safe to say that the one variable that will change or will be something different is your force normal or your tension. And if you think about it this way, force normal is what the force that you feel like on my feet. So if I was standing in a roller coaster, what I'm feeling is the Fn. At the top of the loop, I'd get kind of a feeling of weightlessness perhaps, which means Fn is going to be smaller. I don't feel that force on my feet. At the bottom of the loop, it would make sense that I would feel my force being compressed down. Fn is going to be greater. We can actually just kind of do a quick example if I just throw in some mathematical values. Let's just say, for some simple sakes, we'll make force of gravity like 5 newtons, we'll make centrifugal force 10 newtons, and then of course this one's going to change. Just like before, your centrifugal force is like a net force, so it's equal to the sum of all forces, which is going to be basically force of gravity and your force normal. Now, one thing to keep in mind, directions do change a bit. At the top, Fn is down, Fc is down, Fg is down. So I would often use a negative symbol to indicate that. At the bottom, Fg is down, Fc and Fn are both up. So sign-wise, those become positive, and that's a negative. Makes a slight difference. So at the top of the loop, okay, we'll just say that Fc is minus 10. Fg, is going to be 5 as well, downwards, minus 5, and Fn is unknown. Now, I think you can figure this out, right? If minus 10 is equal to minus 5 plus Fn, Fn's got to be minus 5. Right? Downward direction, that's correct, and a value of 5. Right? Now, at the bottom of the loop, right, what changes? Well, Fg is down still, so it's minus 5, but my centrifugal force is in the upward direction. So now it's a positive 10. So my question now is, what is my Fn value? Well, minus 5 and what equals 10? Well, I think that's positive 15. Positive indicating in the upward direction, which is correct, and 15 is the value, which I would say, compared to the 5 up here, 15 is way bigger, a greater force. Minus 5, positive 15 equals a plus 10. Okay. So we can see how mathematically it works out. We can also hopefully see we have a positive 15 at the bottom for the force normal, and a negative 5 newtons for force normal at the top. Magnitude alone, weaker force normal at the top of the loop, stronger Fn at the bottom. If we look at an example here, so in this particular one, we're looking at a roller coaster, right? It has a radius of 4.80 meters. We read through here. The question asks, determine the amount of force designed to withstand at the top to keep the car from going in the loop. So how much force must the track be able to withstand? So it has to be able to withstand Fn, because that's the upward force that it's got to, I guess, sorry, in this particular case, the downward force that it's got to exert on the car. So same formula, right? Fc is equal to Fg plus Fn. Direction, all three of these should be negative in the downward direction, right? Now, any kind of velocity is going to be the net force. Net force is your centrifugal force. So I have my velocity here, right? I can do basically Fc is equal to mv squared over r. Mass, 4,800 kilograms. Velocity, right there. Radius, right there. So mathematically, if we do the work on that, we should get our Fc. The other one that we got is force of gravity. I got the mass here again, right? So Fg is equal to mass times gravity. So I can take my 4,800 kilograms and multiply by 9.81 meters per second squared. Okay, so if I do it my way, just kind of start with this equation here and put the numbers in. I basically am looking for Fc, and that's Fg plus Fn. Fg is constant, Fc is constant, so I'm just going to calculate those two numbers, and we'll see what we get here. direction. So I basically have to add that 47, and I add that 47, that number there. If I mess around with my decimal places, 1, 2, 3, 4, 5, you can say I get the same answer, down, negative. That should make sense, right? There we go. That's how we do it. Example 3 is a common one, which is a question of basically what's the minimum speed required in order to make a loop, right? In this particular case, it's the same thing, but we're saying, you know, like, what's the minimum? Well, the minimum is you don't feel anything. Like, there's no force normal. You're just basically, it's almost like free fall. What we're actually saying is, in that particular case, Fc is equal to Fg. That's the minimum centrifugal force that you can have, which is, again, there's a certain velocity that'll generate that. Looking down here, we can basically put the values in. mv squared over r is equal to mg. M should cross out because they're the same. And basically, if you rewrite that equation very quickly, you get v is equal to the square root of rg. And that's kind of the formula that is specific to the minimum speed for completing a loop. That formula is on your formula sheet, so it kind of comes in handy here and there. To do this question, at this point here, right, we just simply put in the diameter, sorry, the radius, the gravity, take the square root of those two values, and then you get that. The last example that I'm going to go over is what happens to that roller coaster at the bottom of the loop. So it would make sense, as we mentioned before, that the force normal is going to be much bigger. You feel a stronger compression force or whatever, you know, force on your body as you come around the bottom. Now, mathematically, the numbers are the same. The difference is, in this particular case, Fc is going to be positive and Fg is going to be negative without doing the actual numbers, right? The exact same numbers. So that means in order to get the Fn, right, we're going to have to add Fg to both sides instead of subtracting like we did in the example above. And that's why we end up with a larger number here, which is our Fn. So if I go through the numbers again for you real quick, I'll just put them in. Back in a flash. All right, so you can see here when I put the numbers in, same numbers, the 190,440 newtons, positive, force of gravity is downwards, negative 47088 newtons. So now I have to add both to both sides and end up with 237528 newtons, 1, 2, 3, 4, 5. So the exponent of 5 rounds up to 2.38. And there we go. Now there are lots of other examples, but that's all we're going to go through today because it takes a little bit of time here. The key thing again is anytime you're looking at vertical loops, quickly, what are constant values? Centrifugal force, assuming that V is constant, which it usually is for these questions. And force of gravity. It's going to be constant because mass and gravity should remain the same in a vertical loop. All right? So, keeping those 2 points in mind, try some of the questions, see how you do, and I'll see you back for lesson 34.